ever wonder why calculus gets tricky when dealing with limits? It's all because of the 7 indeterminate forms. These mysterious forms appear when values in our equations sneakily approach 0 or infinity, making it tough to pinpoint the exact value of the limit. But worry not. Understanding these forms is like holding a compass in the vast ocean of calculus. So buckle up as we dive into these 7 indeterminate forms and see how they make our calculus ride a bit bumpy. So, what are these 7 indeterminate forms? Let's break them down. First off, we have 0 divided by 0. This form indicates that both the numerator and denominator of a limit expression are approaching 0 at the same time. Next is infinity divided by infinity. Just like the previous form, this one implies that both the numerator and denominator of a limit expression are approaching infinity simultaneously. The third form is 0 times infinity. Here we're looking at a product of 2 expressions, one which is approaching 0, and the other heading towards infinity. Then we have infinity minus infinity. This form arises when we're dealing with the difference between 2 expressions, both of which are approaching infinity. The fifth form is 0 to the power of 0. This represents a limit involving the exponentiation of 0 with 0 as the base. Then we have 1 to the power of infinity. This form denotes a limit involving the exponentiation of 1 with infinity as the base. Finally, we have infinity to the power of 0. This form signifies a limit involving the exponentiation of infinity with 0 as the base. These 7 indeterminate forms often require some additional techniques to evaluate the limits precisely. These methods might include direct substitution, L'Hopital's rule, algebraic manipulations, or even graphical analysis. As we can see, these forms can get quite complex, but they're all crucial in understanding limits in calculus. Now that we know what these indeterminate forms are, how do we deal with them? Well, there are a few common methods to evaluate these tricky forms. First, we have direct substitution. This involves replacing the variable in the limit expression with its limiting value. If it gives a finite number, bingo, that's your limit. But if it's still indeterminate, we need to try something else. Enter L'Hopital's rule, designed specifically for the indeterminate forms 0 over 0 or infinity over infinity. This rule involves differentiating the numerator and denominator until the form becomes determinate. Then we have algebraic manipulations. Sometimes we can rearrange or simplify the expression to eliminate the indeterminate form. Lastly, we have graphical analysis. By plotting the functions, we can gain insights into the behavior of the limit. So, with the right techniques, we can tackle these indeterminate forms and unlock the secrets of calculus.